So in this one we are going to explore the vectorizing across multiple example things. So we'll just get the concept clear firstly, then we'll dive into the mathematical part. So imagine you have a lot of pictures of different dogs, or a lot of images of dogs and a lot of images of each picture is like special set of numbers that will say this dog has this face, this fur, this color, and etc. So a neural network is like super smart computer that looks at these pictures and tries to figure out what kind of dog they are. It's like computer is trying to solve a puzzle. In the last video we talked about how to make computer look at one picture, one dog, and try to guess what it is. We did this by doing some math that said, okay, if I take this part of the picture, this number in the matrix, and add it to the other part, that number, and then multiply it by something else, that number. But in this video we are going to talk about how to make computer look at all pictures at the same time. So we want to figure out what kind of dog each one is, and so we can show them all together. So to do this we are going to need to change the way we did the math from before instead. So instead of doing just for one picture, one dog, we need to do it for all pictures at once. So if you have neural network with lots of layers, like big stack of pancakes, each layer will be like a special set of instructions that will say, okay, look at this part of the picture, and then just some math magic on it. And to make computers look at all the pictures at the same time, we are going to need to change these instructions so they will say, okay, look at all these parts, all the pictures, and that's where all the magic happens. So we can use something called vectorization to do this. Vectorization is like a special way of writing down what we want computer to do, so it can do it faster and more efficiently. So in this video we are going to talk about how to vectorize these instructions. So they say, okay, look at all these parts, all these pictures. So we'll also learn some new things about neural networks, how it works, and why it's called matrix when we write down what we want it to do. So it's like learning a secret code that only computers can understand. So are you ready to learn more about the vectorization and how to make all the pictures at computer, how to make computer understand all the pictures at the same time? So here it goes then. So we had this neural network kind of thing previously. Let's have these things, x1, x2, and x3. Let's connect each of those with every node that we have. Now let's connect all these things together with this node y, and the output will be y hat. Now we're going to go through some equations. X is going to be a, second layer will equal to y hat, then x1 will be equals to a, second layer, first node equals to y hat, one, right? Then x2 will be similar, right? Like I'll write it for you. It's a true with true and y hat true, right? And this will go on until x to the n, where a second layer and here m will be equals to y hat m, right? So that will be it. So basically what we are going to remember is this is going to be layer, and the second one is going to be training example. Alright, so these are basic things which are going to be there. Now let's look at one piece of code. Alright, so we're going to write some piece of code where, well, we're going to write some things where we're going to have, let's suppose, for I equals to 1 to m this is pseudocode, right? Like this is just for the sake of understanding. Z of first and I is equals to W of I x of 1 plus B of 1 then A of 1 then I is going to be equals to sigmoid of Z of 1, this is square bracket, right, and 1. So to vectorize this whole thing, to get rid of the loop, what we are going to do is we are going to have this matrix, right? So we're going to have this matrix where all the x things will be stacked vertically, x1, x2 up to xm, right? And these things will be nx to m. I hope you remember nx. This concept is coming from previous video. So we are going to get rid of the for loop. So stacking these horizontally to get z2 and a2, which will be capitals, we're going to do those things. So what I'm talking about is it will make sense in a while. So let's suppose z of 1 is equals to w of 1 x plus b of 1, then a of 1 equals sigma of z of 1. Sigma is our activation function, alright? Then z of 2 is equals to w of 2 x plus b of 2, and then a of 2 will equal to sigma of z of 2. and we're going to combine these things. We are going to combine Z, we are going to combine A, and we're going to get capital A here, capital A up true here, and we're going to get capital Z up true here. So stacking these horizontally to get Z up true and A up true capital, that's what we are going to do. So Z up 1 will look like this is our matrix. Z of 1 1, this is square, like round parenthesis, this is square 1, then Z of 1 2 of 2, Z of 1 M. So that's what we're going to do, stack them in the columns. So that's our Z. Then we are going to write A as well. So we are going to have this A1 to 1, A1 to 2 up to A1 to M. Now horizontally, like these things belong to or correspond to different trending examples. If we look or think in the horizontal way, and if we see vertically like this way, then vertical things correspond to nodes, different ones in the neural networks, and that holds true for this thing, then this thing as well, and whatever matrices that we created before these as well, like for this one as well. So in this example, topmost left thing in the matrix correspond to activation hidden unit on the matrix, which will be this thing. So this is our activation in hidden unit in the matrix. So a lot of things in the hidden parts which they will be going on in the matrix. So what is vectorization? Vectorization is a way of rewriting mathematical operations so they can be performed on the multiple elements at once rather than one element at a time. So this allows computers to process large datasets much faster and more efficiently. So in this context of neural networks, vectorization is used to perform matrix multiplication between the input data and the weights of the network, right? So matrix multiplication is one of the fundamental operations in the linear algebra that allows us to combine multiple elements of two matrices into a single element of resulting matrix. So that's the beauty of it, right? So matrix multiplication will be like we are going to have two matrices and we are going to multiply them, and we are going to have something, and that will be our the answer. So how neural networks use matrix? So in neural network, the input data is typically represented as matrix with shape of m comma n, where m is the number of inputs and n is the number of features. The weights of the network are also represented as matrix W's with shape n and p, where p is the number of outputs. So basically, to compute the output of layer, what we are going to have is we are going to perform matrix multiplication between x and w. So y is going to be x divided multiplied by w, where y has shape of m and p. So this means that for each element in ith row of x, we multiplied by every element of jth column with of w, and sum of the results and the resulting element y I j is a weighted combination of all these elements. So vectorization. To vectorize this operation, we are going to write matrix rewrite the matrix multiplication, and that will be performed with multiple elements at once. This will involve changing the way we represent input and input data and weights as matrices, and how we perform the multiplication. So that will be the whole thing. Then we are going to write some code down. So here's the example of Python, which will demonstrate the matrix multiplication using vectorization. Alright, so let's write some Python pseudocode. So here we are going to import numpy as np, right? Then we're going to define the input data and bits. So how we'll do that: x is equals to np.random.rand. That's a random function. And w is going to be np dot now we're going to batch together (32 samples) of the input data. So how we'll do that is batch size, which will be equals to 32, then batch will be equals to batch size, and then we are going to perform matrix multiplication. Which will be np dot batch w. So that's how we are going to multiply the matrix in the Python, obviously. Then we are going to print y dot save, and our output will be looking like this. So if you're curious how our output will be looking like, this is our output, 32, 10. So this code uses numpy's dot function to perform matrix multiplication on the batch samples. So this is our basic Python implementation to just make you familiar with the dot product in the matrix multiplication. I hope this helps. Let me know if you have any further questions. Let me know about those in comment section, and as always, keep hustling, and until then, see you in the next one.